Hello and welcome to the Ecomodernist channel live. My name is Carl Pauls. Joining us is Dr. Tony Milligan, who is a Scottish philosopher. He's currently a senior researcher in philosophy of ethics with the Cosmological Visionaries Project at King's College London. He's the author of the book, Nobody Owns the Moon, The Ethics of Space Exploration. Welcome to the show.
Great to be here.
Amazing. So do you think that you could give us, in brief, what is the ethical questions surrounding space exploration? Isn't it simply empty space that we, as humans, should be exploring?
If we mess these places up, they're gone forever. We have to be kind of cautious with them when there's already so much conflict. If one begins to have an extension of that conflict, or even a further added set of tensions to the terrestrial tensions. So we have to bear in mind that what happens up there inflects and shapes what happens down here, and what happens down here shapes what goes on up there. So it's not Dodge City or something of that sort. It has to be carefully and cautiously nurtured.
You gave us two really good categories. First being the sort of, let's say, the historic provenance of these locations.
Absolutely. There are features that are unique and distinctive, particularly when you get down to the South Lunar Pole, which is the area that everyone's targeting. This is where the US wants to go. This is where China wants to go. This is where Russia wants to go. You have water ice there in areas that are near to elevated crater rims. There are only so many of them. It's really a limited resource. And thinking in terms of some of the interests that you have, for example, in nuclear energy, when one thinks about next generation nuclear fusion, one of the obvious ways in which the moon might be utilised is for helium-3 mining, for helium-deuterium reaction, and so on. And while it may seem that there's abundant supplies of helium-3 on the moon, well, yes, they are abundant relative to the Earth, but you're still talking about parts per billion. And the density declines as you go down through the crushed rocky surface, the regolith of the moon. So you're talking there about large areas of a kind of open cast mining process to extract helium-3. And that's a transformative process that not everyone will buy into, especially when the economics of it look a bit shaky. Who gets to do it? Who benefits from it? What's the rationale behind it? Is it helping to consolidate space infrastructure, or is it a slash and grab raid? All of these issues raise ethical questions about how we steward limited resources, given that we may be in the solar system for quite some time to come. It's not obvious that we can just bounce around everywhere that we like. So what there is, and happens to be limited, it raises questions about the sustainability of human processes and our ability to keep going in space. So it does raise those worries about, is it going to be the case that whoever gets there first is going to try and consolidate their control over patches of lunar territory, which notionally, under international law, which we know is soft law, cannot belong to any individual state or group of states. That's part of the common heritage of humanity.
So helium-3 and tritium as well, important isotopes for energy production in the far future. Is definitely something that I see not mandatory in terms of we don't need to dig up the moon in order to capture these isotopes or produce these isotopes. We could have a large solar sail with helium or hydrogen spread on it, and we could collect cosmic rays, and those would turn the helium and hydrogen into the products we need.
Yeah, you could in principle collect. Or you could go to plan B, which would be to think about the asteroids. Now, asteroids, because they typically don't have the density of the moon, because they're further out when you get to the asteroid belts, it poses some logistical challenges to get out to asteroids and mining for helium-3. And while we might think of the asteroid belt as, there's one over here and over here and over here, actually objects within the asteroid belt turn out to be quite a distance from one another. But there are good environmental reasons for targeting asteroids rather than engaging in extensive lunar mining. So if you want to contain the effects of a human presence, you would champion a process of asteroid helium-3 mining, in spite of the fact that it has some difficulties, and that means cost if it's the private sector that's involved. So you would have to incentivize that in various ways. If it was the only place we could get helium-3 from, but it's not. So we can do it in other ways.
So my background is astronautical engineering, and with regard to helium-3 mining on the moon, this is a long way off. And there are other sources of it, yes. The interesting thing about helium-3 is it's capturable in the top 6 inches or so layer of the regolith, but then it is also a renewable source because it's the sun that streams that helium-3 to the surface of the moon. And so as the sun irradiates the moon, more helium-3 will be deposited. Theoretically, we don't need huge farm tracts of regolith in order to get a usable quantity of helium-3. We're not talking the whole side of the moon. We're talking small farmlands of easily mineable regolith, and it would be mineable repeatedly. The same manufacturing robots would go over it again and again. And so that's exciting.
So consider this scenario. You have a block of terrain. It's already been mined for helium-3. And yes, the sun's still going to be there, and it's still going to be, as it were, seeding that regolith. But the regolith next door, the moon's been around for a long time. So you've got a billion years for the regolith next door to be seeded. And so the density of helium-3 over there is going to be far greater than the density of helium-3 over here. And so the pressure, I think, is to move to where you can get the best return. So I think that we need to be cautious about saying, sustainable resource with the kinds of densities that would make it economically viable. Space poses all sorts of new ethical challenges because it's such a lethal environment. Now, obviously, it's not a terribly safe place to go down in the oceans either, but you're in an environment which can kill you in 50 ways before breakfast and 150 ways after lunch. Makes it difficult to run certain kinds of familiar power conflicts. So there are pressures to change the ways in which we act. The danger that helium-3 mining might at some future point in time, several decades further down the road, lead to systematic damage to the lunar surface. And I've said, okay, let's look out to the asteroids. We can get helium-3 from there. And that sounds like a great fix. But there's a problem. And that is that Mars is strategically located for any systematic mining of the main belt asteroids. So it's almost inconceivable that one would engage in large-scale belt mining without developing infrastructure on Mars in order to facilitate that process, because Mars is strategically located most of the time between us and there. And it gives you a nice surface to work from, and the gravity well is not as deep as on Earth. So then suddenly when you push out towards the main asteroid belt in order to avoid damage to the lunar surface, you have the knock-on effect of the threats to the surface of Mars in the process of that further out mining. When you look at space, there are no easy fixes, and there are no quick solutions that are entirely risk-free and entirely harm-free. So it poses a whole series of conundrums about what are the risks we want to take, What are the levels of damage that we find acceptable? What are the levels of taking things for ourselves rather than leaving them for future generations that might be ethically defensible and allow for a sustainable process of expansion into space?
Really interesting. Actually, it occurs to me there is a ethical parallel when it comes to reproductive health. And I don't know if you've run into this, whereas the basic question we're facing is what quality of life for a person is in the present ought we to compromise for the benefit of that person's future descendants? If you're having trouble, like, you compromise the health of the mother so that she can have a child. But of course, this is the difference between America. We have very sensitive political arguments about this, but it is sort of a question of autonomy versus potentiality. And so I wonder if it's a criticism you've faced where this is a bit reductive to say that, oh, the great potential out in our future descendants is so sensitive and so fragile that we must constrain ourselves. We should use resources as gingerly as possible. We should all live as hermits and monists and deny ourselves a great deal of quality of life for their benefit.
Yeah, I have encountered people who think that's the sort of thing that I'm saying. I did an obscure paper at a conference in Italy the best part of a decade ago, which was about helium-3 mining, because I thought that was going to be non-controversial. And before I knew it, the newspapers were running stories about Scottish philosopher says that mining helium-3 is evil. Now, I don't know where they got the evil idea, whether it was the philosophy that they were objecting to, or the fact that I was a Scottish philosopher. I never quite got the sense of what was running behind it there. But yes, of course, you get into a paradoxical situation if every generation denies itself absolutely for the sake of the next generation and future generations. You just end up with no generation ever really doing anything. But there is something about space that has a concern for future generations built into it. And that is that almost everything that humans do in space will be done by others, not by us, not by this generation. Almost everything. We are only beginning a process that will extend for a very long period of time. There's something about space exploration which makes it a multi-generational activity. And there are aspects of that it's important to bear in mind. One of which is that we should think about whether the projects we start are likely to be continued by future generations. So if the space program gets shaped in ways that are too, as it were, idiosyncratic, or too much about the ideas of one or two individuals who happen to be in unusually advantageous circumstances, then there's a risk that what we start will largely be abandoned in the same way that many of the things that were done 150 years ago are no longer done by us. We don't have an interest in continuing to do the kinds of things that were often done a century and a half ago. We can't think ourselves into that mindset. So we don't want to fall into the same trap. We want to make sure that what we do makes sense to future generations. And because it's such a long-term process, if we do want to have success in space, if we do want to have a human presence which is not radically destructive, which preserves and unique features of the solar system that just can't be accessed anywhere else. If we want to do those kinds of things, then multi-generational thinking is tremendously important. But it's not the thinking of monks. It's just the thinking of people who are reasonably far-sighted about the length of time that it will take for many of the projects that we begin to unfold. Projects such as having a base on the moon. Projects such as having a stable human presence on Mars. I mean, I don't know how many of us will still be alive.
Let me give some time for others to ask questions. Gabe, go ahead. I saw your hand first.
A better way of saying it, exploitation of the moon. I don't see any way of avoiding that. I mean, it's not going to be philosophers who do it, who land there. And they're not taking very good care of the Earth. So
True.
imagine what they're going to do there. I mean, I think that's a non-starter. But here's something, though, concerning that. I believe we've heard of the asteroid redirect mission. Their plans were to direct an asteroid into orbit around the moon. And when you put something in orbit, eventually the gravity of the moon it'll land there. And a lot of these asteroids that are in space, we know they're so valuable on Earth. So I don't see that we would even need to mine, really. You bring them in, let them land on their own, and then just melt them and use them right there.
You're right about the asteroids themselves. There are metallic asteroids, not all asteroids, of course, but
right.
Some metallic asteroids are rich in platinum group metals. Finances don't look right. In fact, it's very difficult to get a viable commercial asteroid mining operation that even begins to think about actually doing it. In a sense, everyone wants to wait for the next generation because the first generation is going to be really, really expensive, and they'll learn a lot of lessons and the technologies will improve. But of course, asteroid redirect missions are tremendously important to avoid threats of an enormous scale, even if those threats are really, really rare. You're talking about really rare events that are of that kind of scale. Of course, smaller events are happening all the time and every 100 years. But the big fear here, I think, is militarization, and that's not a sort of anti-military concern, which is that when you're able to redirect asteroids, then who's to say how that process goes and the enormous threat that could pose, say, if rogue states are able to engage in that practice, or if totalitarian states or authoritarian states led by leaders who really feel that their backs are against the wall, then all sorts of risks can come in with that. So that the process whereby we develop technologies of that sort will work best if there's some degree of international cooperation and some degree of agreed norms about, okay, we're ready to do this, but we're not ready to do that. This would be too threatening. We're too worried about the development of space programs over there and what they might do when they're able to get up there as well. So there are tremendous pressures towards having the inclusion of some kind of consensus and the inclusion of ethical norms, which help to shape a consensus. So it's really difficult to get planetary environmental protection. It's really difficult to get environmental protection for the moon, and to think that that's going to stick. It might and it might not, but there are certainly pressures towards some kind of stewardship of the lunar surface, and that's a kind of common sense that political leaders appreciate as much as anybody else. I mean, they can see the sense of not making a mess up there in the way that we kind of have down here too often.
Sounds like Starship Troopers.
Yeah,
of course. But I guess there is a question of whether or not our political actors are rational. We've already seen spoilage of some portion of our orbital space after India's near-orbit collision testing. And so this is perhaps something that we need to be very firm at the negotiating table about. So thank you for that wonderful response. Tim, go ahead.
Yeah, I used to look at a website called Heavens Above. It identifies all the satellites you can see. Gives you, if you click on it, it'll tell you which trajectory it's on, how long it's been up there. There's a huge amount of Russian space junk, Russian space rocket bodies. What do you think the moral imperative and the technological imperatives of deorbiting and cleaning up space junk? And I see Eugene has pointed out that there may be more problems with space in the geosynchronous orbit than in low Earth orbit, which is really interesting. So, yeah, could you speak to that?
Yeah, this is a big problem. And it's nobody thought in the 50s and increasingly in the 60s that this was ever going to be an issue because space is so big. And it's a bit like people landing in America and thinking, well, this is so big, there's abundant space for everyone. And then you start to get the steady accumulation of space junk, and you start to get worries about Kessler syndrome, about the way in which rogue bits of junk can start off chain reactions, and you suddenly end up with enormous amounts of materials, which then make it perilous, dangerous to travel through. It's tremendously important to tackle the problem of space debris.
The Italians are actually launching a satellite to deorbit one of their little CubeSats, which is, I think, 8 kilograms. And it's this huge deal, and it's just the one satellite. Is there real possibility of deorbiting a decent portion of this stuff?
It's very difficult. I think that eventually the technologies will be there, but we have to be modest about what we can accomplish in the short term and not use technologies which are even more of a danger. So clean-up technologies like space harpoons and so on that rely upon hard impacts upon objects. That would not be my first choice. But I think it's interesting that you mentioned CubeSats there, because CubeSats are part of a larger process of the democratization of space, because it allows people to put satellites up there without vast amounts of money going into it. So it broadens participation, and that's a wonderful, wonderful thing. Of course, we have all of the arguments about, well, are we getting anything new from CubeSats that we don't already have, that isn't already coming in from other sources? But at least in terms of the politics of it, it's a move towards one kind of process of the democratization of space. The interesting thing here, of course, is that democratization can come at an environmental price. So when I see space generally just now is in terms of a kind of conflict between these two things. On the one hand, the more rapidly we expand our activities in space, the more we draw people into putting satellites up there, especially nations for whom that will be their first venture into space. That's a big democratic gain. However, the more rapidly we expand into space, the more sharply we begin to encounter a series of environmental problems. So it's a difficult balancing act between, as it were, on the one hand, democratization of space says go fast, but environmental consideration says maybe go a little bit slower. So as an ethicist, that's kind of where I come in and try to think about how we balance up all of the multiple considerations. But it's going to take us a long time to fix the orbital debris. There are no quick fixes to that. There are no reliable technologies that will allow us to hoover it all up or sweep it all up in some significant portion of it. And the main worry about a lot of the technologies proposed is that they in turn could make matters worse rather than better.
Wonderful response. Thank you. I want to push us into a bit of a tangent, but perhaps it'll get us back to this core ethical question of progress and, in fact, the benefit of humans today versus those in the future. If you have home automation, if you have farm automation, and if you have healthcare and a robust civic infrastructure, you choose to have fewer children. Families, all around the world, once they reach a certain level of energy development, families become smaller. The faster we eliminate poverty, the faster we see all nations develop a healthy and robust economy. And I wonder if a similar argument could be made in terms of development of space. It is the sooner we reach exploitation of extraplanar resources, the sooner we will, in fact, be able to overcome the challenges of that development.
Everything that I say about space and ethics has to be underpinned by good science. It's not negotiable. So I think that the facts are what they are. So I'm going to run more of an idea of a kind of tragic dilemma that we face. Because on the one hand, there is no full overcoming of the problems that we face. There are things that we need to sacrifice. But there is that question about what kinds of price are we prepared to pay for that to happen. Take inclusion, for example. Now, part of the Artemis program that is the launch on Wednesday, but part of that program is geared to put the first woman on the moon and the first person of colour on the moon. And that's continuous with a whole series of measures towards inclusion, both at the level of participation and at the level of project design as well. And that extends to Indigenous peoples and so on. And that's great. In some senses, it's easier to get movement towards gender equality in terms of who, the astronauts who are sent up into space than it is to get gender equality in terms of boiler makers or steel makers or something of that sort. I mean, that's a really big ask. But the way in which we push forward in order to do that does come at a price. And I don't think there's a point in pretending that, yes, we'll push ahead and we'll fix all the problems and there won't be a cost. And nothing that is irreplaceable will be lost. I tell you straight, there will be things that are irreplaceable that will be lost as humans go into space. There will be features of the lunar surface that we will never be able to. We can do copies of them, but it won't be the originals. We will not have the history. Similarly with Mars, there will be features of Mars that are damaged by any extensive human activity on the planetary surface. That doesn't mean to say that we don't engage in the activity, but it does mean to say that we should recognise the cost of it and not think that there is no cost to be paid, and we can magic away the difficulty of having to choose at this point in human history between a series of options, none of which are entirely ideal. And out of those options, we're trying to find the least worst ways of proceeding, rather than ways of proceeding that are going to leave everybody happy and will lead us all to endless basements filled with chocolate and champagne. There is no basement of that sort.
Wonderful. I guess a quick sort of comment on the idea of we're placing women and persons of color on the moon, and that's a wonderful symbolic victory. But when it comes to the question of why this is significant, I would hope it would be symbolic of our tearing down systems of oppression rather than something that is reduced to a symbolic gesture, of course. And so then there's the question, well, great, the Artemis rocket has been launched, but sexism and racism still exist, of course.
Well, I think it's more than symbolic in two respects, one of which is that humanity faces a series of major transformations: the rolling out of robotics, the radical alteration in the ways in which our technologies work in response to climate change, and that process of expanding beyond the Earth, even in modest ways. These are transformational activities. And any minority group who have a place within that really don't have a full place within the world that we're making. And that's a dangerous thing, especially for certain Indigenous groups whose future is unclear. They're not all large scale. Some of the Indigenous groups that exists today will not exist in a cohesive form in 150 years. And one of the differences between those groups on the margins that do and those that don't will be their engagement with technologies and the societally transformative technologies. So that's tremendously important from that side. But it's also not just symbolic in a second respect, and that is in the ways in which space programs themselves get shaped. Earlier on, I mentioned future generations and the difficult problem that what we start will have to be continued by others if our activities are to be fully meaningful. And we are vulnerable to people in the future changing their mind. And we are vulnerable to people in the present exercising a disproportionate influence on space programs and shaping them in their own idiosyncratic ways that will not be carried on by future generations. So how do we get the kinds of space programs that we deserve and need? Well, we try to make sure that what we do is broadly representative of deep human desires and desires shared by large sections of the human moral community, both expansively across the globe and across time as well. So the kinds of inclusion we're slowly working towards are not just about being nice, they're also about making sure that we have space programs that represent a set of ideas that are not exclusive to one section of the community, which would make them more vulnerable, but rather represent something that humanity at large can buy into and can buy into over multiple generations. And that's why inclusion of multiple sorts is the best safeguard for the sustainability, the long-term sustainability of appropriate space programs.
This will be our last question for the program.
No, I was just thinking about all this inclusion stuff and brought up the naming of the Webb Space Telescope. Apparently, James Webb was not exactly as woke back then as his namesake telescope is supposed to be. And I was just wondering, do you think there would be any sociological value in renaming the telescope?
Yes, there's a great deal of care that's taken over naming processes because naming and valuing are intimately connected with one another. If you think about the cooperation between NASA and the Navajo, which led to 50 Navajo names, various objects encountered on Mars, and that's only within the last few years. That we do that, we try to avoid the naming of features on other planets after great colonial explorers. Of course, there's always going to be a Columbus everywhere in space, just as there is down here. But it's about the ways in which people can feel invested in processes. And if you adopt naming conventions that are just fundamentally offensive, then it makes it harder to see space as having a full potential for inclusion.
Wonderful. So with that, I want to thank you for your participation. Tim, I'll start our closing. Missions first.
Tony, we've ended these programs lately with the phrase, our motto, I hope, and that is emissions first, peace and justice will follow.
Thank you, everyone.
Please subscribe to us on YouTube, Ecomodernist channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.